Hello, Year 5, and welcome to your maths lesson for this week. So this week we are looking at multiplying by two-digit numbers. So last week we were looking at multiplying by one-digit numbers using a range of different methods. This week, today we're looking at using a partitioning method, and then the rest of the week we're looking at using the column method for multiplying by two-digit numbers. So let me share my screen with you, and our starter activity is linked to what you've done last week. Can you work out the missing numbers using the clues? So your clues are the four digits being multiplied by 5 are consecutive numbers. That means that they are in a row. So 5, 6, 7, 8, for example. The first two digits of the product are the same. So the first two digits of the answer are the same digit. The fourth and fifth digits of the answer, so fourth and fifth digits, add together to make a third. So these two digits, when they're added together, they equal this number. Do pause it, do have a go with this. You might want to try some trial and error and see what you find, but can you find the correct answer? Have a go, pause the screen, and then when you're ready, skip on to the next slide and I'll show you what the answer is. Okay, so hopefully you had a really good go with that. It did take me a little while, so you might have needed to try it for a bit longer. So your answer needs to be 2,345 times 5 equals 11,725. We look at the rules. The four digits being multiplied by 5 are consecutive numbers, 2, 3, 4, 5. The first two digits of the product are the same, both 1. The fourth and fifth digits add the answer, add together to make the third. So 2 add 5 is 7. So 2,345 times 5 gives you 11,725. If you found a different answer, then do email it over to me and I will have a look and I will cast my eye over it and see if it works. We are looking at multiplying two-digit numbers by two-digit numbers, and we're using a partitioning method today. Partitioning is where we split numbers into their place value. So today we're going to be splitting numbers into their tens and ones, and we're going to be using something called the grid method to multiply those numbers together. Does involve some adding at the end as well, similar to our partitioning method previously from last week. So remind ourselves of some of the different ways that we might see multiplying in questions. So it means to add equal groups together. So we might say lots of, repeated addition, product of, groups of, timesing, or multiples. So our first focus sum is going to be 23 times 16. We could say that as 16 lots of 23, the product of 23 and 16, the 16th multiple of 23, 23 groups of 16, 23 times 16, or 23 multiplied by 16. We could also see it as 23 out of 23, but I didn't want to do 16 of them. But we could see it as repeated addition as well. So for our method, I've showed you how you would lay it out in the column method, but this time we are going to do it slightly differently. So we're going to partition both numbers. So I can partition 23 into 2 10s and 3 1s. And I can partition 16 into 1 10 and 6 1s. And that is what that looks like. And what I'm going to do is I'm going to then lay these numbers out in a grid method. So you can see down this side, I've got 23 altogether, but partitioned. And on this side, along the top, I've got 16 partitioned into 10 and 6. And I've got my grids here. And by partitioning them, I've split this sum into 4 easier sums. And those sums are 10 times 20, 6 times 20, 10 times 3, and 6 times 3. And this is what it will look like in a visual representation. So there's 23 in Dean's and there's 16 in Dean's. So there are our sums that I'm going to do in each one. Just the same as in partitioning, if we were doing 23 times 6, I would do 3 times 6 and 20 times 6. You can do the same thing with this. We just end up with a couple more sums. This can be much easier because we can use our knowledge of our times tables and apply it to multiples of 10. For example, if I know that 2 times 6 is 12, then I know that 20 times 6 will be 120. So I can use that information to help me instead of having to work out what looks like a larger sum. So I'm breaking it into easier, manageable chunks. Now, this is what it looks like as a visual, physical representation. So in this box up here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lots of 20. And if I were to count all of those together, that would tell me that part. I've got 3 lots of 10 here. And if I go back, I can see that's the sum that I would have. I've got 3 lots of 6 here, and I've got 6 lots of 20 here. So I've shown that in that physical visual representation so that you can see what it links to when we've made it. But going back to our sums, I always start off with the ones that I know off the top of my head. So 3 times 6 is in my times table, so I know that's 18. 3 times 10, I know is 30. With this one, if I know that 2 times 10 is 20, then 20 times 10 must have an extra 0 added onto the end of it. So that will give me 200. And if I know that 2 times 6 is 12, then 20 times 6 will be 120. Now all I need to do to find my answer is add all of those together. So I've put them in order from largest to smallest to make it a bit easier for me. 0 plus 0 plus 0 plus 8 is 8. 2 plus 3 plus 1 is 6. If I can get it to work, let's just copy you. And then 2 add 1 is 3. So my answer should be 368. And I've managed to get that by partitioning those numbers and trying to make it into a more manageable sum. There we go, 368. So we're going to do this one again together, but I'd like you to try it first. You don't necessarily need to do the physical representation because it ends up being quite a lot, but I will show you how to do sort of a quick version of it at the end of this. But do have a go at partitioning the numbers and trying to make this grid. I know that some of you will know how to use the column method, but I'd like to save that for next week and to have a go using this method. One of the things in maths is for you to be able to show that you understand how you get an answer by using different methods to do that. Okay, so let's have a look through and see how you got on. So first of all, I can partition these two numbers. I can partition 34 into 3 10s and 4 1s. I can partition 26 into 2 10s and 6 1s, which looks like this. It's always useful to actually have that written down so that you can see it. I'm going to draw my grid out, and I'm going to place 34 down the side and 26 along the top. And then I can put in my sums. So I know that if I follow this down, it's going to be 30 times 20, because that's where these two intersect. 4 times 20 for that one, 30 times 6 for that one, and 4 times 6 for that one. Now I'm going to start off with 4 times 6 because that's in my times tables. I know that 4 lots of 6 is 24. And as I look through it, if 4 times 2 is 8, then 4 times 20 must be 80. And then for the next one, if 3 lots of 6 are 18, then 6 lots of 3 10s must be 18 10s, which is 180. And finally, if 3 times 2 is 6, then 3 10s times 2 10s must be 600. So 600 will be my answer there. I need to add all of those together. So 0 plus 0 plus 0 plus 4 is 4. 8 plus 8 plus 2 is 18. So I need to carry 1 across. 6 plus 1 is 7, plus the 1 is 8. So my answer should be 884. I've managed to get that by splitting those numbers and partitioning them. Now, this is what it might look like if I was doing a sort of a quick version of it. It's not the easiest to do on a computer, I have to admit. But instead of drawing out a whole scene, I might use a line to show a 10. I might use a dot to show a 1. So this has got 3 10s and 4 1s. Now we know that when we multiply 10 by 10, we get 100. So that's how we end up with 600s here, because I've got 10 times 10 there, 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 and 10 times 10 there. Here I've got 6 lots of 30, so I can see 1, 2, 3, 4, 5, 6 lots of 30, and then down here I've got my 6 lots of 4 to make 24. Now, What I would love to see is some people having a go at using both of those methods. I know they are a little bit time consuming, and for that reason, I've only given you two sets of questions here. I've given you the arithmetic questions, and I've given you an open-ended challenge. So I'd like everybody to do the arithmetic questions. If you're looking to stretch yourself, see if you can show your method using the visual representations as well. Just use lines and squares and things like that, though. Don't draw the deans out, otherwise you will end up being there for centuries. So what I'll do is I'll show you your arithmetic questions, have a go with them, and your answers are towards the end. The challenge question is quite open-ended, and because there's a lot of different answers, I haven't put an answer in there for you. But when you send me over your answers, I will be able to check through them, and I'll tell you if you are correct, and it sort of narrows it down as you go through the question. Here is your open-ended question. Have a go with that and send me over your answers, because like I said, there are quite a lot of different options for answers. Some of them say 3 possible solutions, and that's a really good way of furthering your maths knowledge. But here are your answers for the arithmetic questions. As always, send me over any questions that you have. Don't worry if you find that method a bit confusing. I have to admit, it took me a little while to get my head around it. I like it because it's quite visual, but once you've learned the column method, you probably won't want to use that method. But it is a good way of partitioning those sums up so you can see how that works. Send me your answers for the open-ended question as well, and good luck.